Don't you just love technology? Technology is the best thing ever when it works. And then when it doesn't work, it seems like the world is falling apart. This is episode 12 of the Boiler Wild podcast. Well, welcome back. If you are listening to this is Boiler Wild. My name is Eric Johnson. I don't have a fancy intro to this podcast, but on this podcast, I talk about boiler industry topics as well as personal development, as I believe the two go hand in hand, as you can't be great in your career if you are not trying for excellence outside of your career. WILD is an acronym that stands for work hard, invest in yourself, lead others, and develop yourself into a person of excellence. So back to the technology part, I recorded the previous podcast, episode 11, and I tried to edit it, schedule it, all this stuff, and it would just, my podcast app thing was glitching out. Tried for 40 minutes to get it to work. And I've learned with this online subscription software stuff that when something isn't working, it's normally having issues and it's not going to be resolved immediately. If you've already reloaded the page, you just have to give it time. So I just gave it 20 hours and we are back and able to upload podcasts. So that's episode 11, put out slightly late on a Monday morning, July 21st. But we are back. We are rolling. Excited for another week, educating the people, educating the world about boilers. And if you didn't listen to episode 11, that's fine, but I would go back and listen to it. It is about CSD-1, kind of what CSD-1 is. It's a very brief overview. I don't know how interesting it is to talk about code and code in depth. I would talk about the whole standard and go by section if people found that interesting, but I don't want to have a 4-hour podcast on CSD-1 unless somebody tells me to. If you email me or DM me on LinkedIn and you say, hey, I want a 4-hour podcast on CSD-1, I will make it. And it will be for you, and I will call you out by name on the podcast. Now I'm going to get somebody to do that, and now I'm going to spend 4 hours talking about CSD-1. But anyways, I love CSD-1 and how it helps to make boilers safer and how it brings more regulations around boilers. So I'm not a huge fan of government regulations. The government normally makes life harder for the average citizen, but in certain areas, government regulations are needed. And one of those is boilers. If we left corporations alone and did allow them to do their own thing, we would have so many boiler explosions and accidents. We still have so many accidents. We don't have a ton of boiler explosions in 2025, but I would say we have way more expensive boiler repairs and or boiler replacements from improper maintenance, which is a sign of poor education and training. And those corporations need to be held to a standard, and somebody needs to hold them to that standard, and that is what the national board has kind of come around with. The national board has a commissioned inspector program, which I believe all inspectors for boilers in the United States have to be commissioned by the national board. And that program has been great, along with ASME and their codes and standards. And you have to force corporations to follow these codes and standards by passing them into law, and states do that. However, states do that in varying capacities, and every state is different. Some states are very aggressive with the laws that they pass, and other states are pretty lax. A state like California is very aggressive with the laws it passes, especially for boilers and emissions. And that's why you see California having low NOx regulations, which is great. Like there seems to be this thought, this binary thought that if you're not for reducing emissions, you're for pollution. There is a happy medium. There is a good enough, I would say, when it comes to reducing NOx and emissions. We should always strive to reduce it, but overreaching government mandates are sometimes not helpful when trying to reduce emissions. It's always push for more, push for more. In the case of California, they constantly reduced their emissions. So they were 30 ppm NOx, and now, then they do sub 9, sub 5, and eventually, now they're going to outlawing gas boilers. They're, outlawing gas cars. So they just keep pushing it. It's never good enough. And that often doesn't meet reality. Like, you can't have 100% electric boilers. That also just puts the emissions somewhere else, which I don't know a ton about, but supposedly it's more efficient. But the electric grid right now cannot handle it. So anyways, that's kind of what government does and how they constantly push for stuff. But the CSD-1 standard was made in the 70s, and it was made to help protect the public around boilers. It's an in addition to standard to the boiler and pressure vessel code. I covered this on the previous podcast, but I want to remind you that the in addition to part is important because the standard is not required in all jurisdictions in the United States, and the standard does not tell you how to build a boiler. It is based more on safety and control devices of a boiler, and like I said, it's only like 58 pages, if I am remembering that correctly. So you want to just be mindful of where the standard falls into place in the industry and how to use it. But the topic for today is the field report. The CSD-1 field report is essentially the most important part of the standard, as it shows that a manufacturer has built and tested a boiler to the CSD-1 standard, and that a contractor has tested these controls and safety devices to the standard. The field report is in the non-mandatory appendix of the standard. The non-mandatory appendix is not part of the standard, it is not required. The field report in its format in that non-mandatory appendix can be changed. Manufacturers will delete information on that report that doesn't apply to boilers that they make. Contractors will change it, but for the most part, generally people will use that field report. They'll probably also scan it 400 times, and you end up with a field report that looks like trash. That's kind of why I made the boiler and CSD-1 field report. The report is written or formatted from a contractor's point of view, and it helps contractors to fill out a CSD-1 form for a boiler when you have a tablet and you have a person in the field looking at the boiler. The form is very digital friendly. Put a lot of thought into the flow of the form and how the information flows. I also added a little bit more information that helps a contractor out, like the national board number. That is not part of CSD-1. That is not part of what ASME does. But when a contractor looks at a CSD-1 form, it is very helpful to also know the national board number of the boiler you're looking at. Sometimes boilers can have missing identification or get confused, and you may have two boiler ones at a site. They may be in different buildings. The serial numbers may have not been filled out, but the national board numbers won't be the same either. So you can identify a boiler most of the time by the national board number. So that's just a helpful piece of information when you're looking at a CSD-1 report. Different states have different requirements for CSD-1. In the state of Michigan, you are required to complete a CSD-1 field report every year for a boiler. And you have to leave the report in the boiler room or submit it to the inspector so that they can look at the report and make sure that you completed it correctly. I assume they're making sure you completed it correctly. I'm sure a lot of inspectors just want to see that the report was filled out. I don't know how many actually look too closely at it. And I am fuzzy on the requirements, and that's every year for, I believe, all boilers, but it may not be all boilers. Don't quote me on that. It's at least high pressure steam boilers. It may be every other year for hydronic boilers or low pressure steam boilers, but that's just an example. There are other states where a CSD-1 report is only required to be filled out on the boiler startup. However, CSD-1 also says if the state has also adopted the CSD-1 standard, CSD-1 also says that the field report also needs to be filled out under certain conditions. And those conditions will dictate when you need to fill out the report, and they essentially prevent you from making changes to the boiler and not realizing that the changes have affected how the boiler runs. In the CSD-1 standards, section CG 442, it says that anytime you replace a burner, control, alarm device, control wiring, or a primary flame safeguard, or you move the boiler location, you need to complete a CSD-1 field report for all the control systems and safety devices. So basically what that means is if you replace a low gas pressure switch on a boiler, you are required to complete a full CSD-1 report for that boiler, not just test the low gas pressure switch, say, yep, it works, and then leave. I don't know how closely contractors and states follow that requirement. Like I said, I'm not experienced in all states. I'm trying to learn what happens in different states and keep everything straight. As I previously mentioned, states will adopt different laws and have different ways of doing things. More states are more lax. There's also a difference between the laws and versus what contractors actually do. If a inspector is not asking for stuff and making sure contractors stay in line, that the state's boiler licensing board is not making sure contractors stay in line, contractors are left to basically self-govern, and that can lead to a lot of different things. But I can almost guarantee that contractors are not filling out the CSD-1 field report when they are required to every single time. It is so easy, change an air switch, replace the air switch, be like, yep, good to go, get out of there, make sure the air switch works, and leave. Completing a whole nother field report form for a boiler takes a little bit more time. Customer may not want to pay for all that. Customer may need the boiler. The boiler will have to keep being shut down because you're testing all the safeties. So that really falls back on the contractor to self-govern and say, hey, this is what's required by the state. This is what the standard says, and we're going to abide by that. So anyways, if you install a new boiler, replace the burner, control, alarm device, control wiring, primary flame safeguard, or you move the location of the boiler, you are required to complete a CSD-1 form. Or if, in the case of like Michigan, if you are required to complete the form on an annual basis. CSD-1 does not say anywhere in the standard that you have to complete a field report form on an annual basis. That is going to be a state law that states pass in addition to the standard. That list that I just read off is the only time CSD-1 requires a field report. CSD-1 does require annual maintenance per the manufacturer's directions, but that doesn't necessarily mean that you're filling out a CSD-1 field report. Let's get into the field report. So the order I am going is going to be the boiler and custom field report. If you want this field report, it is included with the Foundations of Controls and Safety Devices learning course. The learning course helps you learn the CSD-1 standard and gives you step-by-step training and guidance on how to complete a field report properly. So you'll have on the field report, you'll have general information, which is something I added to the field report. And this is your customer name and like work order number, job number, and equipment ID. If you are completing a CSD-1 form for a boiler that's installed, they're on the normal recommended report in the non-mandatory appendix of CSD-1 standard. There's no equipment ID field, and most customers, contractors refer to boilers by a customer assigned equipment ID. And that can get confusing, especially if you fill out 3 forms. Now you're left trying to figure out which CSD-1 form is for each boiler based on the serial numbers, which may or may not be correct or filled out depending on how exact you are. So it's easy to have equipment ID at the top, or in addition to the job number, work order number, so that you can refer back to when you completed that report and maybe any other notes that a contractor would have noted with that report. The next section I have is installation location. This is where the boiler is installed. This is just the name of the location and then contact information, address, city. Then you go into unit manufacturer, and this is the primary unit manufacturer of the boiler: Cleaverbrooks, Hearst, Fulton, Unilux, anything like that. That is going to be most of the time the person that made the pressure vessel, but not all the time on smaller hydronic boilers. A lot of the pressure vessels are third party made and shipped in, and then the primary manufacturer builds the boiler around the pressure vessel. So just keep that in mind. If you're looking at ASME information that's on the pressure vessels, may be different than the manufacturer's name on the front or side of the boiler. And that just goes in the manufacturer's contact information. I did include a list of manufacturer's name with a with this guide that I made. And it has all the information. It helps you fill out the information faster. Then it goes into unit identification. And this is the model or product number of the boiler. So every boiler will have a model number. Model numbers are not unique to a boiler. So if you have 3 boilers in a boiler room, the model number will be the same if all the boilers are built alike. And a lot of the times they are. That's a common number of boilers to have in a boiler room is 3, and it's normally a 2+1 scenario. 2 boilers are required for the load, and 1 boiler is a backup. If you have 2 boilers in a boiler room, then it's going to be a N+1, which 1 boiler required for the load, 1 for backup. If you have a manufacturing facility with 1 boiler and they claim that that boiler is critical for the process, it's not actually critical because they only have 1 boiler. That's a sidebar that we'll get into another day. Then you have ASME number. That's if it is Section 1 or Section 4. Section 1 boilers are any steam or vapor boiler rated with maximum allowable pressure, MAWP, above 15 psi, and then a hot water boiler with maximum allowable working pressure above 160 psi or maximum temperature rating above 250 degrees. That's going to be a Section 1 boiler. Section 4 boilers are steam boilers operating pressures not exceeding 15 psi, and hot water heating and supply boilers with pressures not exceeding 160 psi and temperatures not exceeding 250 degrees. So if you just have a standard hot water boiler, it will probably be a Section 4 boiler. Most hydronic systems are operated under Section 4 boilers with a maximum temperature of 250 degrees. You can also have another rating of boiler that is slightly lower than that with a maximum temperature of 210 degrees. That can also be Section 4 boilers. You can tell what a boiler is by the ASME designator on the pressure vessel. So I think they call it a clover leaf, but now ASME has updated the designator. So they have like a clover leaf with ASME diagonal inside of it, and then they have the designator below it. So if you see the clover leaf with ASME and then you see S, that means it's a power boiler. Power boiler is just a fancy name for a Section 1 boiler. Then you can have miniature boilers, which is an M. Miniature boilers is what the name sounds like. They are miniature boilers. They just very, very small boilers. Normally, the only time you'll see that in commercial and industrial spaces are very small, localized boilers that are probably electric for like sterilization. That's a very popular use of a miniature boiler. Then you have electric boilers, E, and electric boilers are boilers that use electricity to generate steam. You can also have A, which is a boiler assembly. For Section 4 boilers, the marking will be H, so that'll be a heating boiler. Section 4 boilers are called heating boilers. Even though it may be used for a process, the boiler is still called a heating boiler. If you have a HLW on the equipment, that means it's a hot water heater. That is a different classification under Section 4. But most of your Section 4 heating boilers are going to have the H designator. Then I put the national board number. That's not going to be a piece of information that you find on the non-mandatory appendix version of the field report, but I think it's important. Serial number, That is the serial number of the boiler. Each one will be unique. That is a manufacturer assigned serial number. Sometimes serial number is just random set of letters. Sometimes the serial number actually means something, and you can tell like the boiler horsepower or the input or the fuel based on the serial number. You have UL and CSA numbers. UL is just a testing agency. CSA is the same way. UL is Underwriters Laboratories. CSA is Canadian Standards Association. And the year built, you can find the year built on the equipment data tag or on the ASME information that is either stamped into the pressure vessel or is on a plate that is attached and welded to the pressure vessel. Then you have steam or hot water, and this is where you kind of start breaking it out. Is this a steam boiler or is this a hot water boiler? If it's a steam boiler, you write down the MAWP and the safety valve capacity, which you will find on the pressure vessel once again. If it's a hot water boiler, you write down the MAWP and the maximum temperature and the minimum safety valve capacity. The boiler unit, this could be a fire tube boiler, water tube boiler, cast iron boiler. That is the construction of the boiler. Fire tube boilers have combustion gases and fire inside the tubes, water outside the tubes. Water boilers have combustion gases outside of the tubes and water inside of the tubes. Cast iron boilers are made of cast iron. Number of modules. Modular boilers have a single housing, but it has multiple heat exchangers, burners, gas trains, blowers, and controls. The Riello array boiler is a popular modular boiler. It has, for example, it can have like 6 heat exchangers in it. So that's 6 heat exchangers, 6 boilers, 6 gas trains, and it can turn those heat exchangers on and off. The benefit of that is you get some wild turn down numbers with that, as you can have 1 heat exchanger going on a very light day for the load, or you can have 6 heat exchangers going when the load is a design day. Then you have boiler unit input capacity, output capacity. You will normally find the input capacity that is on the equipment data tag, and then the output capacity, if you do a simple calculation on efficiency, you can find the output capacity. There's different ways to calculate boiler efficiency, but for the CSD-1 report, I just did a simple output capacity. So if your boiler is 80% efficient, you just multiply it by 0.8 on the input capacity and get the output capacity. Like I said, that is just simple efficiency. That is rough. That doesn't actually calculate all areas of the boiler. There's different ways to calculate it. That's a topic for another day. Then you have burner information, burner manufacturer, model number, UL, CSA, serial number. Not every boiler will have a burner tag on it. For example, say like a Lochinvar Crest or a Fulton Endura boiler. They are a packaged hydronic boiler with a burner that is made by a third party, but it is part of the boiler and designed for that boiler, and is not going to have a separate burner information. The burner information you'll see is only when the burner is made by a different manufacturer and then mounted to the boiler. In the case of fire tube boilers that are Scotch Marine boilers, or like water tube boilers that are like D type, O type, larger water tube boilers, you'll have a burner that is mounted to the front of the boiler, and that burner can be a separate manufacturer or it can be made by the same manufacturer. So like Cleaver Brooks makes their own burners and will label them Cleaver Brooks, and Cleaver Brooks also makes their own boilers. Cleaver Brooks also owns Industrial Combustion, which is a burner company. A lot of Cleaver Brooks burners are just industrial combustion, and it just depends on who's buying, is how they label the burner and what color they paint the burner. Then you have fuel information. Basically, you'll select what kind of fuels you're using. Most fuels are, most boilers are just natural gas. If you have dual fuel, you can have, say, number 2 fuel. You are also starting to see dual fuel boilers that are natural gas and electric. That's technically not like dual fuel technically, but it is dual input. So that's an interesting new design. Gas manifold pressure. That is the measured gas manifold pressure at high fire. And that is marked by the unit manufacturer. So the burner manufacturer, boiler manufacturer will mark where to measure the gas manifold pressure. That will usually be in inches of water column. Then you'll have high fire gas pressure switch setting, low fire gas pressure switch setting. And those are important settings. There are requirements for those settings based on CSD-1. If you want to learn more about that, I cover that in depth in the Foundations of Controls and Safety Devices learning course. Then you have oil nozzle pressure, which is going to be the supply pressure to your oil nozzle. If you didn't know already, the oil needs to be atomized in order to burn it. And the way you do that is increasing the pressure of the oil. And you can do that 2 ways. Is if you just do pressure atomization, you are going to increase the pressure sometimes, say, around like 300 psi. If you have air atomization, you can end up with lower oil nozzle pressures as you are inducing air into the oil nozzle, which helps to atomize it, and that's going to be compressed air. That's in addition to the combustion air that is part of the combustion process. And then I also added like some numbers for electric boilers, like kilowatt input. Is it have an element boiler or electrode boiler? Element boilers use resistance through like an electrical element. Electrode boilers use resistance through the water. Electrode boilers very rarely are going to be covered by CSD-1. Most electric boilers are expensive and larger boilers that are going to exceed the equivalency rating of the 12,500,000 BTU rating of what the CSD-1 standard covers. Then you get into the safety devices section. So everything I just went through is the equipment information, ratings, manifold ratings. That will vary all by the manufacturer. And if you want to find out what the manufacturer has said, the manufacturer will fill out that information. If you are filling out the information, you want to verify that information. If you have a boiler and change the burner, you obviously will have different information than what the manufacturer originally shipped the boiler with. So always verify the information. If you are looking at another CSD-1 report, never blindly copy information from another report, even if a manufacturer completed it. Hopefully, a manufacturer can complete information correctly on a report, but they're human too. Not always will the information be correct. Then you have the safety device testing section. I made it really easy to complete this section. So CSD-1 requires that you fill out the manufacturer information. So that's going to be the manufacturer name. Then you have the model number of the control. You'll have the operational test date. So if you complete a CSD-1 form all in one day, you're just going to keep repeating the date. And then I have check boxes for pass, fail, and NA. Pass is going to be that the control functions properly per CSD-1 and has no outside conditions and issues visually that you see that could fail the control. Fail is the control does not function properly per CSD-1 or has visual conditions that can cause the control to fail. So, for example, you can have a low water cutoff that is functioning properly but has corrosion through all of the electrical contacts inside the head of the control, like, for example, a McDonnell Miller 150S float. If the bellows assembly leaks, you get water into the head. If you can imagine, if you know what a 150 head looks like, it is kind of like a flat tray that can hold water, and water slash steam will get up in there, corrode all the electrical. And when that happens, the control is bad and needs to be changed, even though it may shut down the boiler. So that's an example of when you would mark fail. And then I would mark NA if, one, the control is not installed on the boiler, and that is the only time I would mark NA. And that helps me to just kind of start checking off safety controls. Like I said, you will have a general form for the boiler. You will not have a custom CSD-1 format for each boiler manufacturer. Each contractor will have a general form. Manufacturers may have a custom form that is slimmed down to exactly the information that they make for their boilers, but that is not realistic for a contractor to have 10 different CSD-1 forms that are all customized for manufactured equipment. It's easier just to have one form. And when you're filling out that one form, you will have a lot of safety and control devices that are not installed on the boiler, and you can end up looking like you're not completing the form. And it also leaves ambiguity for somebody else looking at the form. So say a supervisor looks at a form or an inspector looks at a form and they see that, uh, 8 of the 10 safety and control devices were not checked. The line is just blank. So does that mean that 8 of the controls are not installed on the boiler? Does that mean 8 of the controls were not tested yet? Like, what does that mean? So when you can mark NA, that means that somebody consciously looked at that line item and said, this control is not installed on the boiler. And I included in the training that you should not be marking NA if you cannot test the control. If for some reason there's some condition that you cannot get a control into a test form, you need to not mark pass, fail, or NA, but you need to mark that in the notes of the note section of the CSD-1 form of why you did not test a control or why you were not able to test a control. There's some conditions. Sometimes you can not get a high pressure gas switch to trip if the range of the switch is too high, and say whoever selected the switch selected the range and the proper switch setting of the switch is the bottom end of the range. And now that the proper switch setting is the bottom end, you can't like turn down the switch setting, and you don't have time, and the customer doesn't want to pay for you to pull off the switch of the boiler or to have the proper valve set up to manually test the switch and pump it up manually and calibrate it. That's a discussion for another day. Not every situation is perfect, and I understand that. And I like to make forms that account for imperfect situations. And that is what the NA part of the form is for. Now, getting into the details, we'll briefly go over this. I went over this in detail in the Foundations of Controls and Safety Devices learning course that I put together that is on the Boiler website. I would highly recommend it. You will learn a lot. You'll be farther ahead than if you go out and just do on-the-job training with somebody else. Depending on your trainer, there are great trainers out there, but most of the time your trainer will just be a senior service technician. They can, one, tell you bad information, even if they mean to tell you good information. They may just be telling you information that they think is true, that is not true. That is a downside of on-the-job training. You can also get the situation where the trainer is not prepared to train people and just kind of does the report themselves, and you end up with a lackluster training experience, and you don't really learn how to fill out the information. You just watch them fill out the information that day, and then your supervisor expects you to know how to complete the report. And then you'll quickly find out when you're completing the report yourself that it can be very intimidating staring at a blank CSD-1 report. And that is why I made the field guide to take you through step by step completing a CSD-1 report. And that field guide you can lean on instead of calling other people or reading the CSD-1 standard, which will only tell you what is required for the standard. It does not specifically reference, hey, this is exactly how you complete a CSD-1 field report. I wish I would have had this training when I started completing CSD-1 forms, and that is why I made this. I made this for my past self, and hopefully there's one person out there listening to this that feels the same way and was in the same situation that I was and wanted to learn. And this is your opportunity. I have paved a road for you to learn quickly and stop struggling and make sure that you get it right. So if you want to check it out, that's my plug for the Foundations of Controls and Safety Devices learning course on Boilearn website. You can find that at boilearn.com, BOILEARN.com. Now the operating controls section of the report. Operating controls will shut down the boiler but not cause an alarm. So the primary low water cutoff on a steam boiler, it may cause a low water light to come on, but it will not cause the boiler to alarm on the safety control most times. Context, that is on a steam boiler. So on a steam boiler, high pressure steam boiler, you're required to have at least 2 low water cutoffs. And this is kind of what makes it hard to talk about safety controls, as the safety control will vary based on what kind of boiler it is and how large the boiler is. But on a high pressure steam boiler, you'll have 2 low water cutoff controls. The primary will shut down the boiler, but it will not cause a safety shutdown and lockout. If the boiler is able to refill then the boiler will automatically start again and does not require a manual reset. Then you have like forced circulation, which is just flow sensing through a heat exchanger. You have steam pressure, which is going to be your operating pressure control of the boiler. So that's like your thermostat on your furnace at your house. When your thermostat shuts down your furnace is not going to alarm. That is a normal condition. That is what the operating pressure control does. Shuts down the boiler. When the boiler gets to the operating pressure control set point, that doesn't mean something is wrong with the boiler. That just means that the boiler is producing more steam pressure than the system needs and shuts down. Then you have water temperature. That's the same thing. Operating water temperature control of a boiler. That doesn't mean that something's wrong with the boiler when the boiler shuts down. That just means the water in the boiler is getting too hot and that the system is not requiring that hot water and will shut down the boiler. Then you get into the safety controls. Safety controls will start causing a safety shutdown and lockout of the boiler. So you have a low water fuel cutoff. This is going to be your auxiliary low water cutoff of the boiler for a steam boiler. This is your secondary low water cutoff. On a steam boiler, if your primary does not shut off the boiler and the water level keeps dropping, you will have a secondary low water cutoff that will shut off the boiler and cause a safety shutdown and lockout and requires a manual reset. The manual reset is for you as an operator or service technician or building owner, whoever, to know that, hey, there's something wrong with the boiler and it's not going to run unless a physical human comes into the room, looks at the boiler, and determines what the problem is and then pushes the manual reset. You can also not have a boiler with a problem that trips on the low water cutoff. So if somebody turns off a feed water pump and the boiler is still steaming and running, the boiler will go down on secondary low water cutoff and then turn off. That doesn't mean there's a problem with the boiler. That just means that there was a problem in that scenario with the feed water going into the boiler, and that's just because somebody shut off the feed water pump. So you just flip on the feed water pump, boiler's going to fill up to a normal operating water level. You reset the alarm on the flame safeguard, you reset the low water cutoff, and the boiler fires away. That doesn't mean that the boiler has a water issue. That just means that it did have a water issue, but there's no fix outside of, we forgot to turn on the feed water pump, or the feed water pump rotation didn't work correctly. But now that you have a feed water pump running, it's all good to go. Boiler's ready to go. It can be as simple as that, or if the boiler's shutting down on secondary low water cutoff and you don't know why it's shutting down and there's an issue with the control or there's an issue with the water level, that's when you need to start looking into deeper issues than, we forgot to turn on a feed water pump. On hydronic boilers, not all hydronic boilers are required to have two low water cutoffs. On newer style hydronic boilers that are like of the condensing style, most times they will only have one low water cutoff, unless your jurisdiction says that you have to have two low water cutoffs, and then the manufacturer will install a second low water cutoff on the boiler. CSD-1 goes into all kinds of different rules that you need to abide by when you are installing the low water cutoff. I summarize those rules in my field guide for you to reference. I will not go over all those. The forced circulation, once again, this is applicable on boilers that require forced circulation to prevent overheating and heat exchanger failure. It is a primary safety control and temperature sensing device. It monitors the temperature differential in the boiler heat exchanger to detect insufficient water flow. So some manufacturers will have a heat exchanger that they say, hey, if the flow goes to 0, the boiler heat exchanger will not be damaged. We're good with that. The boiler will shut down, but it won't be damaged. And then other times manufacturers will say, yes, if you go to 0 on the heat exchanger on the flow or go to low flow, the heat exchanger will be damaged, and we're going to prevent that by putting in a flow switch or putting in temperature sensors that monitor the differential across the heat exchanger. There's different ways to do it, but not all heat exchangers will have a flow switch. There are other ways to monitor the flow through a heat exchanger. You can do that across pressure drop. Each boiler is different, but don't be surprised when your hydronic boiler does not have a flow switch. Then you have high steam pressure limit. The high steam pressure limit is required to have a manual reset. That manual reset does not need to be part of the control, although I would highly recommend that it is part of the control. And most of the time it will require a dual reset in that case. But making it part of the control helps you determine what control tripped. Sometimes on boilers, especially if the boiler just has like a Honeywell 7800, if a high steam pressure limit trips, the 7800, depending on how it's wired, but a lot of the times it'll just go into standby, as the high steam pressure limit could be wired into the or it could be wired into the interlock circuit. I believe I'm saying that correctly, but essentially it just shuts down the boiler, but doesn't cause an alarm on the 7800. But you will constantly search and be like, man, why is this boiler not starting? And then you'll eventually find that the high steam pressure limit is tripped. And then you'd be like, oh yeah, duh, we hydroed the boiler when we did the inspection and I forgot to reset it. Ask me if I've ever done that. It is easy to spot that a high steam pressure limit is tripped if it is a mercury switch. As you can see, the bulb will be rocked over. Mercury switches are great for learning, but Honeywell no longer makes the pressure troll with mercury inside, and many places the mercury switches have been replaced. To my knowledge, I don't believe that there is any law that requires a mercury switch to be replaced. If you talk to the manufacturer, they will say, yes, replace them, because they know that a mercury switch is old, but that doesn't mean that the switch is bad. And due to the quality of build, some mercury switches are built to a higher quality than the snap pressure switches you'll get on a pressure troll from Honeywell these days. So don't believe, if you're a contractor telling customers that, hey, you need to replace your mercury switches because they are obsolete and no longer supported or whatnot. Yes, they are obsolete. Yes, you can't buy them anymore off the shelf brand new from a distributor, but that doesn't mean that they're bad and absolutely have to be replaced. There's no code that I think says that, although a lot of places, especially like schools, don't like to see mercury, even if it is in a small vial in the boiler room. Once you tell them, oh, that there's mercury in the school, they'll start freaking out and they'll want the pressure switch replaced. The high water temperature limit, same thing. It requires a manual reset. The manual reset does not need to be part of the limit. it can be part of the flame safeguard or safety relay, or, in these days, the touchscreen of the boiler, the PLC. But if you get a standard Aquastat from Honeywell and you want a high temperature limit, it is easy to just order the manual reset one, and then it's got a little red button on the front that will also mess you up. And I've gotten a lot of service calls. Hey, our boiler doesn't run. There's no alarms. It won't start. And then, you start asking them questions. They're like, oh, yeah, we had a power outage. So the power outage won't affect the boiler, but with a hydronic boiler, if you're a smart cookie, you'll know that a power outage, when there's no backup system, the pumps will immediately stop. And if the boiler was firing and the boiler immediately loses flow, it is very probable that even though the boiler shut down immediately, that water temperature will quickly rise as it lost flow, and it will trip the high water temperature limit. In that case, you just tell the customer, hey, you're going to be looking for this limit, little red button, push that button, make sure your pumps are running, and you're good to go. You can prevent a service call or, more downtime if you're smart about it. Then fuel safety, shut-off valves main. These are the safety shut-off valves for the boiler. CSD-1 says that you can have a boiler with one safety shut-off valve if the burner input is less than or equal to 5 million BTUs per hour. But the safety shut-off valve needs to have proof of closure, which is shortened to POC. Proof of closure is just a switch that is inside the safety shut-off valve, and that switch essentially monitors the physical function of the seat of the valve and makes sure that the valve is actually closed when it's supposed to be closed. Most safety shut-off valves, you cannot install a proof of closure switch. You need to order it with the switch. I guess some valves you can field install it, but I would just always order it with a proof of closure switch. So when you're looking at two identical valves on a gas train, they are probably not identical. Look at the model numbers. If the model numbers are different, the proof of closure switch is probably what is different. You can have two safety shut-off valves in series on a 5 million or less BTU per hour boiler. That's also fine. Then if you have greater than 5 million BTUs per hour, you're required to have two safety shut-off valves. And then one of them needs to have proof of closure. The proof of closure one is normally the downstream one that is closest to the burner, although nothing in the CSD-1 requires it to be closest to the burner, but I guess that's kind of what manufacturers do, and that's what I've always done. You make it closest to the burner, last line of defense before the burner. You're going to want to inspect the actuators, valve bodies for corrosion. The Honeywell fluid power actuators are notorious for leaking red hydraulic oil. And when it starts leaking red hydraulic oil, the actuator is failing. And a lot of inspectors don't like to see that and will have you replace it. Although I have seen actuators leak oil for 10 plus years and still keep functioning. The oil is not a safety issue per se. Now, if it gets all in the valve and everything, yes, it is, but a safety shut-off valve fails closed, and the oil is used in the valve to provide power to open the valve. So if it leaks all the oil out, the valve just won't open or won't open fast enough, and then the boiler will fault. But like I said, if the oil's leaking and starts getting all in the seat and inside the valve body, that is a problem, and you want to change it. But most inspectors, as I said, they see leaking oil, they want it changed, and I would always defer on that judgment of something is going wrong or starting to go wrong. We recommend replacement of this, but leaking oil out of a valve will not keep the valve from closing. It will just keep it from opening. That is unless you start getting it into the seat of the valve. Then you have pilot safety shutoff valve. Only one pilot valve is required for CSD-1 boilers. 2 pilot valves are required for NFPA boilers. But on CSD-1, only one safety shutoff valve is required. You're going to want to make sure that the valve holds pressure. Same with the safety shutoff valves. You want to make sure that the seats are tight. You can do bubble leak tests. I included instructions how to do a bubble leak test with some nice pictures in the learning course. Next, you'll have a atomizing medium switch, and that is going to be a medium that helps atomize the fuel. This can either be air or steam. Most of the time on a CSD-1 boiler, it's going to be air. Steam atomization is not super popular on smaller boilers and on newer boilers. You will find that on the larger boilers that are mostly water tube boilers will be steam atomization. Air atomization is much easier, but also requires an air compressor. So you need to make sure that that is working. The air compressor will be normally part of the packaged boiler. It'll be installed by the burner or installed along the rail of the support of the boiler. All depends on what the boiler manufacturer supplies. Then you have combustion air switch. The combustion air switch is vital for boiler operation. You want to get in your head that the combustion air switch doesn't check that the burner fan motor is turning. It checks that if the burner fan is actually providing air pressure. The whole point of the combustion air pressure switch is to check air pressure. And if you just do it, oh, yep, the burner fan motor came on, yep, we're good to go. But for some reason, the combustion air pressure switch isn't made. Well, that must be bad, so I'm going to replace the switch. That is the wrong thinking. I've had it where the combustion air pressure switch wouldn't work and the burner fan is coming on. So you're like, oh, everything should be great. Well, then you start opening things up and you find out that the end of the burner fan motor, the shaft has sheared off and the fan is just sitting in the housing, not turning, obviously, because the shaft for the motor has sheared off. And now you're not creating air pressure. So even though that the motor is turning, you're not creating air pressure. The fan can also blow apart. Most of the time, you'll be notified of that, and it'll make a ton of noise. But you can have fans blow apart and nobody around, and the motor's turning, and combustion, you'll lose your air pressure as you no longer have a properly functioning fan, and the boiler will shut down. So you want to make sure that you understand that distinction. Then you have high gas pressure switch that monitors gas pressure. Normally closest to the burner, you can have them installed before the safety shutoff valves. That is less common, but on a typical gas train in North America, most burner manufacturers install the high gas pressure switch downstream of the safety shutoff valves. There's requirements around where the set point needs to be set. No more than 150% of the boiler burner's main manifold gas pressure. If the boiler burner does not specify a switch setting, then a low gas pressure switch will typically be before the safety shutoff valves, but it's not required to be there. It can be after the safety shutoff valves, but before the safety shutoff valves, the set point either needs to be the burner boiler's manufacturer's specified gas pressure or no more than 50% of the boiler burner main manifold pressure. Low gas pressure switch stops the boiler from running on too low gas pressure, which can cause lean combustion, which can cause high amount of CO and other issues. Low oil pressure, you want to make sure that you have enough oil pressure being supplied to the burner. If your oil pressure drops because you run out of oil or your oil pump doesn't work, your low oil pressure switch will shut off your boiler. Then you have high oil temperature, low oil temperature. This is less common these days, but there are still places that burn heavier fuels. So fuel oils like number 5, number 6 are heavier and require heating in order to flow because they are so viscous. I believe that is correct. They have a higher viscosity. So high viscosity, I believe the definition of viscosity is the resistance to flow. So if you put a high viscous oil like in a jar and try to dump it out, it'll kind of be like molasses. So kind of think like of a thick syrup. But then number 2 fuel oil, which is super common, is essentially diesel. So if you ever have seen diesel, it essentially acts like water. It flows everywhere and does not require heating. So the high oil temperature, low oil temperature, just make sure that you're heating the oil correctly, not too hot, not too cold. Purge airflow. This is purging the combustion chamber of air, and that is going to be important to prevent ignition of combustion gases that may be built up in the combustion chamber. You may have leaking gas valves that are leaking gas into the combustion chamber. CSD-1 regulates for power gas burners and mechanical draft atmospheric gas burners that 4 air changes within 90 seconds are made. So that is why when you turn on your boiler, the fan starts and it doesn't just immediately light. It is pushing fresh air through the combustion chamber and pushing out any gases or combustion gases that are left over so that it can light, hopefully, in a safe environment with clean, fresh air with no extra fuel available. Then you have flame safeguard. This is going to be what sees the flame and basically is the main brain of the boiler. On larger boilers, your flame safeguard will be an accessory onto addition of like a PLC with way more controls. On smaller boilers, your flame safeguard will be the brain. So like a 7800 on a standard boiler or even like a FireEye E110, the flame safeguard makes all the decisions for the boiler. So it's going to open, close the fuel valve, monitor all the safety switches and pressure or temperature of the boiler. So on the flame safeguard, you're just making sure that it's in good condition, working properly, not overheated. Flame detector, this is what actually sees the flame. You have couple different kinds of flame detectors: ultraviolet, infrared, flame rod, thermocouple. It doesn't matter what kind of flame detector you have. Your burner manufacturer will select it for the type of burner or boiler. You are just going to do a like-for-like replacement if that's the case. Like I said on the previous episode, you're not required to engineer the boiler. The boiler manufacturer has already done all the engineering. You're just maintaining it. So if it's got an ultraviolet flame detector, just change it with an ultraviolet flame detector if it no longer works. So that's 4 types of ways to see the flame. You're just going to test that they are functioning properly. And then you have low fire start. Most boilers will light off in low fire. If you have a premix burner, you will light off a couple notches above low fire, so maybe like 30%, as a mesh burner will require a little bit more fuel input to get lit, but once it's lit, it can modulate down. But a standard water tube boiler with a power burner or a Scotch Marine boiler with a power burner will light off in low fire. You want to make sure that the air damper is in the low fire position before you light. A lot of people will do this with linkage burners with a Honeywell module forward motor. They can also do it with a end switch on the air damper. if you have parallel positioning, they will do this just with the feedback of the actuators of the air damper. So you won't really have a low fire start switch on most parallel positioning burners. But even on a parallel positioning burner, you can have, in addition to the feedback on the actuator, a manual switch that is connected to the air damper that is an end switch. That actually senses the actual position of the air damper, as if the actuator were to come loose from the air damper jack shaft, the actuator can make the proper position, but that doesn't tell you that the air damper is in the proper position. The system assumes that the actuator is connected to the air damper. But having an end switch on the actual air damper is proving that the air damper is in position to make that end switch. Then the last section of the field report form is safety and relief valves. A safety valve, if you don't know, is for vapor service. A relief valve is for fluid service. So a steam boiler has safety valves, and a hot water or hydronic boiler has a relief valve. When I say the term safety relief valve, that is just a general term. And I covered this in a prior episode of the differences between that in a more in-depth. Then you have manufacturer, model number, and size. Manufacturer of the valve, Apollo, Kunkel, Cabraco, Watts. That's going to be on the valve data tag of the safety relief valve. The model number, that's going to depend on the manufacturer. Then you have size. It's only going to be one size, but that's going to be the inlet size of the valve. So if you have a size of 1.5, that's going to mean that the valve inlet is 1.5, but most likely the output or the outlet of the valve is going to be larger at like 2 inches. Then you have capacity of the valve, either rated in BTUs per hour or pounds of steam per hour. That's going to be on the valve data tag. And then the last and most important section is going to be the signature section. So you're going to have the equipment manufacturer section for a signature, and then you'll have representative company name and signature. And you will probably not get a signature from the manufacturer. If you are filling out a CSD-1 report in the field and you don't have a manufacturer's representative there for you, you will not get a signature. You can skip that step, as the manufacturer will have made their own report and signed it themselves. You're making a different report and then signing it. So it's okay to skip the manufacturer signature section. But for you, when you sign a CSD-1 form, you are saying, I completed this form to the best of my ability. It is correct, true, and everything. So that is why you want to make sure that you are completing all the safety device checks and completing all the information correctly. If you are pencil whipping the form, if you are copying the form and just completing the form, just get it completed to show somebody that you completed it, and the form is not a product of you actually making sure that the boiler is running safely and abides by the CSD-1 standard, you are doing everything wrong. But your signature should mean something. When somebody sees your signature and name on the bottom of a CSD-1 report, they should know, oh yeah, this is good. If you lose branding and lose credibility and start cutting corners, people can see your signature and be like, yeah, that doesn't mean anything because I know he didn't fill this out properly because I've seen him do it. That's not a good situation. And don't lie to yourself. I've seen it done. Contractors copying CSD-1 reports, people pencil whipping the reports just to get it done, just to show the inspector. The inspector never checks. They don't think it matters. That completely defeats the purpose of the CSD-1 form. Like I said previously, the purpose of the form is not to show a completed form. The purpose of the form is to make sure the boiler is running safely. And if that's all you remember out of this episode, that is what I want you to remember. That The whole purpose of the CSD-1 is not to put more regulations on you and more work and, why do I got to complete this form? Everything works. Everything's good. No, the form just shows you and others that the boiler is running correctly and that you made sure of that. So you need to make sure that you take the form seriously and complete it to the best of your ability, and make sure that your signature and name at the bottom of the form mean something. It should mean that to others that the form was completed correctly. As you build a personal brand around that, building your brand as a operator, service technician, anything, people should come to realize that this person does this correctly and I can trust this report. If somebody knows you constantly cut corners and you make a report, they're going to be skeptical about what's in the report, as they're like, yeah, I know this isn't true because I know he cuts corners and I saw him do this when he wrote this. And then that throws all credibility out the window, and that is not a good situation. And then the last section I added was comments. This would be where you put, if you were to mark an NA on a safety device, you could put a comment of why you couldn't check the function of that device, or anything else that you saw on the while you're doing the check and need to be noted. This is not where you want to write like service report information. You will be filling out hopefully a service report in addition to a CSD-1 field form, or if you're filling out a logbook, that is where you're going to want to write more detailed information. And you can also copy the comments that you made on the report into your service report. That is also helpful, as not everybody may read the comments or see the comments on the CSD-1 report. Depending on your paperwork setup, electronic, paper, how it gets pushed around, who sees it, and whatnot. But yeah, hopefully that was a good overview. We're at 85 minutes, longest podcast so far. Blew through this one. If you want more in-depth, all videos, me and my beautiful face talking, animating the CSD-1 standard, how to complete this report, more in-depth learning about CSD-1, go to boilerin.com. Highly recommend the learning course. Like I said, I can't say this enough. This is something I wish I had when I was learning and looking for answers online. Instead of calling people and relying on people and trying to trust and verify what they're telling me and feeling unsure about what I'm doing, I wish I had training like this. And that's why I made it. So if you want to, I would really appreciate it. Go check it out. boilerin.com. If you loved this podcast or any other podcast, please rate it 5 stars right now. And if you hated it, just send it to somebody who you hate so I can waste their time too. Maybe I can woo them over and they'll love the podcast and start listening. So I would really appreciate that. If you have any suggestions for topics, or you want to be a guest or have guest recommendations, you can email me, eric.johnson@boilerin.com, or you can send me a DM on LinkedIn. That is good too. If you're on LinkedIn, send me a connection request if we are not already connected. Just search my name, Eric Johnson, and you'll find it. I hope you got some value out of today's podcast. Stay wild.